So now today we are starting with the three-phase supply. Okay, in the three-phase supply, this is the most important unit, or you can say module for Manipal. Okay, why is it so? Because in the three-phase, three questions will come. Okay, every time they'll give you the three question of 10 marks, and these three questions are fixed. Like one question is of 3 marks, another question is of 3 marks, and another question is of 4 marks. Okay, so if you'll study this, then you'll get 10 marks. And what are those three questions? There are two types of question. Either they'll give you the numerical based on star, okay, or they'll give you the numerical based on delta, or they'll give you the numerical or maybe the derivation also, the based on power measurement. So basically what I want to say, there are only three topics in this module, and those three topics will definitely come in your exam. So no, you if you'll cover this 10 marks, then you will never get back in BT. Okay, so that's why this module is very important for you. So let's study in detail about it. First of all, as you know that supply is divided into two parts. One is the single phase supply, another one is the three phase supply, right? In the single phase supply we'll have single wire. In the three phase supply we'll have three wires, red, yellow, blue. And three phase is further divided into two categories. What are those two categories that we have studied in the DC circuit also? One of the category is star connection and another category is delta connection, right? So let's study in detail about the star connection first. Star connection is like this. We'll have windings and we'll have three wires. One of the wire is red, another wire is yellow, another wire is blue, and where all the wires are connected, that point is known as neutral, and neutral is denoted by N, right? So in this case, if we'll have a plain wire, right, this one is having a plain wire, then that is represented by line, and if we'll have a winding wire, then that will be represented by phase. Correct? Okay, understood this thing? So first of all, we'll mark the current. Like suppose it is connected for R, so it would be IR. It is for Y, it would be IY. It is for B, it would be IB. And this is for the neutral, so it would be IN. Got it? Now this point is neutral. So IR, IY, IB, these are the currents which are flowing through the plain wire, right? So technically this one is known as line current, and line current is denoted by IL. So can we say that IR is equal to IY is equal to IB? Tell me. Here in this, yeah, this is the why this is equal, because this one is I am telling you for the balanced load. Okay, basically there are two types of loads in your syllabus. One of the load is balanced load and another load is unbalanced load. So in case of balanced load means this winding resistances are equal. If the winding resistances are equal, then the current would also be equal. But in case of unbalanced load, winding having different resistance, so the current would also be different. First I'm telling you for the balanced load, and then I'll tell you for the unbalanced load, because in your syllabus both are the cases are there. Okay, now let's consider about the phase current. Like this is connecting between N and R, so it would be INR. This is connecting between N and Y, so it would be INY, and this is connecting between N and B, so it would be I and B. So can we say that IPH is equal to INR is equal to INY is equal to INB, right? Now tell me, any doubt? So in this case, as you can see that INR and IR, current is not diverting. So can we say that IR would be equal to INR, right? Similarly, can we say that IY would be equal to INY, and can we say that IB is equal to INB? So wherever we are getting the N, that means this one is the phase current. Why phase? As I told you, phase is the thing which is flowing through the windings. So this one is the phase current and this one is the line current. So from here what we conclude that line current must always be equal to the phase current in case of star connection. Okay, so you need to write it down that IL must be equal to IPH. Okay, derivation will not come in the for you in Manipal, but you have to learn the concept. That's why I told you what is basically the line and what is basically the phase. Now similarly we'll learn about the delta connection. Again, draw the star connection like the previous case we have done. Now in the last case we have marked the current, now we'll mark the voltage. Okay, this is R, this is Y, this is B, again this is neutral. So the voltage between R and Y would be equal to VRY, right? And as you know, I'm marking the voltage between the lines, so we can say that it is a line voltage. Voltage between Y and B is the line voltage VYB, and the voltage between R and B is VRB. So what we can say, VL is equal to VRY is equal to VYB is equal to VRB. So these are the all the line voltages, right? Because I marked across the plain wire. Similarly, we can have the voltage between N and R is VNR, voltage between N and B is VNB, voltage between N and Y is VNY, right? Now you have to tell me that whether in this case VNR is equal to VRY, yes or no? So VNR and VRY is not equal, right? So phase voltages are which one? VNR is equal to VNY is equal to VNB. These are the phase voltage. So from this what we can conclude that VL is not equal to VPH, but there is some relation between the line voltage and the phase voltage, that is VL is equal to √3 VPH. Okay, this I am considering, as I told you, I am telling you for the now for the balanced load only. So there is one relation between the line voltage and phase voltage. I am not telling you the derivation because derivation will not come in a paper. So VL is equal to √3 of VPH. Okay, understood? So what we conclude finally, that in the case of star connection, VL is equal to √3 of VPH and line current is always equal to the phase current. This you have to remember from numerical point of view. And one, you know that according to Ohm's law, V is equal to IR, and now we'll use V equal to IZ. So if Z is in phase, current would also be in phase, so voltage would also be in phase. We'll always use this formula. We never use this formula, VL is equal to IL into ZL. Write it down and cut it down, because maximum of the student do this mistake. They use this formula. This is not the formula. This formula doesn't exist basically. This is the main formula. Okay. Now sometime then in the question they'll ask you the active power, reactive power and apparent power. As you already know the formula, active power formula is VI cos phi, reactive power formula is VI sin phi, and apparent power formula is VI. But now we have to consider for the three phase, because this is for the single phase, right? For the three phase, the formula is √3 VL IL cos phi root 3 VL IL sin phi and root 3 VL IL. Or if we want to calculate in terms of phase, then in that case the formula is 3 VPH IPH cos phi, then 3 VPH IPH sin phi, and then 3 VPH IPH. Okay, now units also. Active power unit is, as you know, watt. Reactive power unit is VAR. VAR means volt ampere reactive, and apparent power unit is VA. Understood? Now see, the next one is delta connection. Okay, numericals I'll tell you later. First see the basic concept. In the delta connection, as you know, delta is like this. Similarly, we'll mark the line voltages and the phase voltage as we have done in the case of star connection. Like suppose this is R, this is Y, this is B. Okay, this is 1, this is 2, and this is 3. Got it? So now first of all we have to mark the voltages over here. We'll mark the line voltage. Voltage between R and Y is VRY. Voltage between Y and B is VYB, V by B, and voltage between VBR is VBR, right? So these are all the line voltages. VRY is equal to VYB is equal to VBR. Similarly, we'll mark the phase voltage. I differentiated by changing the number. Like voltage between 1 and 3 is V13, voltage between 2 and 3 is V23, voltage between 1 and 2 is V12. So it would be VPH is equal to V13 is equal to V23 is equal to V12. So now I am asking you the question, V12 and VRY is equal or different? Tell me. So V12, like as you can see, there is a plain wire. This is also the plain wire. So the potential across this plain wire is same. So can we say that VL is equal to VPH? Means the line voltage is equal to the phase voltage, right? In the star connection, voltage is different, but in the delta connection, voltage is same. Now similarly, you have to mark it for the current. Okay, this is again R, Y, B, 1, 2, 3. Now for current you mark. So this one is the phase current, IPH. So this one is the line phase current is I13, I23 and I12. All this one is for balanced load only, and the line current is IR is equal to IY is equal to IB. So what you conclude from here, tell me, is IR equal to I12? Yes or no? No, no. So what we conclude that IL is not equal to IPH, but there is one relation, that is IL is equal to root 3 IPH. Again, derivation you don't need to do, that's why I'm not telling you. So line current would be equal to root 3 times of phase current. Okay, so what we have see, there is star connection and there is delta connection. For the balanced load, first of all I am telling you, for the balanced load, line current is equal to phase current, but in delta line current is root 3 times of phase current. Okay, in the star connection, VL is equal to root 3 VPH, and in the delta connection, VL is equal to VPH. Active power, reactive power and apparent power is same for the star and same for the delta as well, and we'll have one formula, that is VPH is equal to IPH multiplied by ZPH for the star and delta both. Okay, now for the unbalanced load, for the unbalanced load we have to consider the angle as well. See how we'll see, there is R, Y and B. This is R, this is Y and this is B. So angle between R and Y, like if we'll see it from this, all these are 120 degree apart. Difference between each angle is 120 degree. So the angle between R and Y is how much? Minus 120 degree, because it is on the negative side. Similarly, angle between R and B is how much? Minus 240 degree, right? So if I'll see from the positive side, angle difference between R and B is plus 120 degree and angle between R and Y is plus 240 degree. Yes or no? Note this down. Now again, for the unbalanced system, these formulas are present in your handbook as well. This one is for star. As you know, in the star connection, voltage is different, right? And like if I'll draw a diagram, this one is R, this one is Y, this one is B, and this one is the neutral. So as you know, the line voltage is VRY is equal to, not equal basically now, VL is equal to VRY, VYB and VBR, and the phase voltage is VNR, is VNY and VNB, right? So we'll have one relationship for the unbalanced. This one I'm telling you for the unbalanced, that what is the relationship, that VRY would be equal to VRN minus VYN. Okay, means this is the relation of line voltage and the phase voltage. Similarly, VYB is equal to VYN minus VBN. Similarly, VBR is equal to VBN minus VRN. Understood? Current is same, so line current is equal to the phase current, again in the case of star connection. Similarly, for the delta connection, as you know, the delta current is different or voltage is different? Tell me. In the delta connection, current is different or voltage is different? Voltage. So this is V line voltage is VRY. No, in the delta connection, current is different now. So the current, line current is IR, IY and IB, right? I'm marking the current as same, like IR is here, Y is here and B is here. So the current between R and B is IRB or IBR. Current between IRY is IRY, and the current between B and Y is IBY. Basically, we'll move it according to this sequence: RYB, RY, YB and then BR. So I'm changing this because in unbalanced it matters. It would be IY. Okay, as this is a standard sequence, R to Y, so I marked IRY, Y to B, so I marked YB, and then B to R, so I marked BR. This is a positive sequence. So I phase is how much? IBR, comma IRY, comma IYB. So there is one relation, that IR is equal to IRY. See the sequence I'm telling you. If IR is there, then R to Y minus B to R. Okay. If you want to calculate IY, then in that case, what would be the sequence? Y to B No, y to b and r to y. So it would be I YB minus IRY. Similarly, you tell me for IB. Formulas are very, very important. Time they'll ABC also. This one is given in your handbook, but ABC is not given. You have to understand it, and then you need to remember it ultimately. Okay? Write out all these formulas. See, this is the numerical from your paper April 2019. This one I'll tell you, next one you will do it by your own. In this, what this a three-phase supply, voltage is 400 volt. Okay, so whatever they mention you the voltage, that voltage would always be the line voltage until and unless they didn't mention. They didn't mention over here now that which voltage they have given it to you, so we have to consider that voltage always as line voltage. Okay, clear? Now they said frequency is 50 hertz, so whatever they'll give it to you, write it down. Frequency is 50 hertz. AC supply is applied to delta connection. So as you have already studied in the delta connection, line voltage is equal to the phase voltage, and the line current is equal to √3 times of the phase current. This you need to remember that in delta connection we have to use it. So that's why I wrote it separately in the form of formulas always whenever they'll give you the question. Each load consists of 10 ohm resistance, means resistance is how much, 10 ohm, and inductance is how much, L is how much, 20 millihenry. Determine the phase and line current. So can we get the impedance from R and L? ZPH. ZPH is in the form of R plus JXL. R value they have given us 10 ohm. J value we know. XL is how much? 2 into pi, means 3.14 into F into frequency. L is how much? 20 millihenry. Inductance 20 into 10 raised to power minus 3, right? After solving we'll get 10 plus j 6.28, that is the value of ZPH, means impedance we are getting like in this form. Understood this portion? First of all tell me. Now after this we need to calculate phase and line current. First of all, as I told you, we need to calculate phase only. For this we need voltage and impedance, right? Remember I told you the formula that VPH is equal to IPH multiplied by ZPH. Yes or no? ZPH we have already calculated, that is 10 plus J 6.28. So let's write it over here, 10 plus J 6.28. IPH we need to calculate. VPH value is given, right? VPH value is how much they have given? 400, because line voltage is 400 and that is equal to VPH. So we can write down at it as 400 volt. Got it? Clear? Now in this case basically there will be three cases, one for R, one for Y, and one for B. So there is formula basically VRY is equal to the phase voltage only, or we can say VRY. If we'll consider the angle also, first angle is always 0 degree. Okay, second angle is always minus 120 degree, third angle is always minus 240 degree. Remember I told you the sequence. This is, if I'll take it in reference with R, then VRY is 0 degree. If I'll take it in terms of Y, so we can say VNR is this one, and VNY is minus 120, and VNB is minus 240. Write it down. Back to the question. In this they said we need to calculate current. So as you know, VPH is equal to IPH multiplied by ZPH. Z is how much? 6 plus J 10.28. No, sorry. 10 plus J 6 point. Yeah. 10 plus J 6.28. IPH we need to calculate. First angle is what? 400 angle 0, right? So from here we'll get which value? I R Y. Remember I told you VRY is equal to IRY into ZRY. Okay. Second one is VYB is equal to IYB multiplied by ZYB. Impedance is same, 10 plus J 6.28. IYB as it is. VYB angle is 400 angle minus 120, right? Similarly, third one is VBR. As you know the sequence na, RYB, R to Y. This one is R to Y. This one is Y to B, then B to R. VBR is equal to IBR into ZBR. So it would be IBR. We need to calculate. Impedance is same for each and every case. Voltage is same but the angle is different, so the third angle is always minus 240. Okay, I'm writing like this: VYB is equal to IYB into ZY, this one and this one. Write down these formulas also in your handbook, in your notebook. And from here, can you get IRY? From here, can you get IYB? And from here, can you get IBR? Tell me. So after solving, we'll get this value of IRY, right? We need to convert it into the polar form, then we'll get this value. Similarly, IYB, I'm telling you 33.87, because magnitude will same in all the cases. Now only there is an angle difference. Angle would be minus 152.14 and 33.87 angle would be 87.86. okay, so now this one, tell me, this IRY, IYB and IBR, these are the line currents or the phase current? These are the phase current. Okay, so you know, got to know the phase current. Now we need to tell the line current according to the question requirement. They ask you to calculate the line current and the phase current, right? Phase current is this one. Line current we can get it by using these formulas. I told you now in the delta connection, if you know the phase current, can you get the line current? Yes or no? So IRY is how much? IR is how much? IRY minus IR. So I'm not calculating, I'm telling you the direct values. IR, you can do it in your homework and tell me if there is any doubt. 58.66 angle minus 62.14, and IY you will get it as 58.66 angle minus 182.14, and IB you will get it as 58.66 angle 57.859. okay, now we got the phase current and line current. Then we need to calculate power factor. Power factor is, you know, cos phi. Cos phi is how much? R by Z. R you know 10 ohm, and Z also you know it. Calculate it, convert it into the polar form. Okay, convert it into the polar form at whatever the magnitude of the Z you will get it, you have to take that R by Z. Okay, next one is, yeah, that is in the rectangular form now, but you need to convert it into the polar form, then you will get the exact magnitude of the Z. Okay, you can't take this one 10, no, you need to convert it into the polar form. Polar form means the angle form. Next one is the total power consumed. P is equal to root 3 VL IL cos phi. Root 3 is there, VL is there, IL is there, cos phi is there, right? You can get it, all these values. But remember one thing, in the power we never take the angle. We need to take the magnitude of voltage, that is 400. We need to take the magnitude of the current. IL means the line current. Line current is this one, na? IR, IY, IB. That is 58.66. 58.66. And the power factor, after solving, you will get it as 0.846. So after solving all this, you will get the power as 34.416 kilowatt. So I'm telling you all the answers so that you can cross check your answer. This would be your homework. Okay. KVA is kilowatt ampere. See, in this case they said a 3-phase 400 RY means line voltage is how much? 400 volt, right? Supply feeds an unbalanced 3-wire star connected load, so it's a star connection, right? So as you know the formula, VRY is equal to IRY into ZRY, correct? VRY is 400 angle 0, IRY we don't know, ZRY they have given as 24 plus J7. So can we get the value for IRY? Similarly, as you know the another formula, VYB is equal to IYB into ZYB. VYB is 400 angle minus 120. IYB we need to calculate. ZYB they have given, that is 9 plus J40. So from here can we calculate IYB? Oh, sorry. This is a star connection now, so we need to convert it into phase. And how will we get it phase? PL is equal to root 3 of VPH. So VPH is how much? PL by root 3 means 400 by root 3, right? So divide by root, divided by root 3, and so on. Got it? So in the star connection, line current and phase current is equal, right? Line current and phase current is equal. So whatever the value of IRY you will get it, that would be equal to the IR only. Okay, IYB is equal to IY and IBR is equal to IB. So you have to be careful. You have to remember, in star current equal and in delta voltage is, got it? Now I'm giving you the homework. Try to do this in your homework. 1 minute. This is your homework question. Try to do it. If you'll not get it, then I'll solve it in the next class. Bye bye.